All right. So I've made a bunch of lectures at this point on Zoom, but I've never done it on a tablet before. So this is a new experience for me, but I'm going to go ahead and start sharing my screen now. Okay. And I'm going to open up OneNote or OneDrive. That's where I have the notes for 1.1 saved. And yeah, I'm going to try to just do this taking notes on the tablet. Okay. So let's talk about statistics, okay, and kind of introduce the concept a little bit. So statistics as a mathematical area of study revolves around data. And we'll talk exactly about what we mean by data later on. But for now, just suffice it to say that data is information that's collected for members of some group of interest. So statistics is the science of collecting, organizing, summarizing, and analyzing data. And so we'll talk about each of those four things, although we're not going to talk a lot about each of them. The first step, collecting data, we'll talk about that briefly in chapter 1. And the reason we're only going to talk briefly about that is just because, you know, good practice for collecting data is really determined by your field of study. So we'll give some general guidelines, but we're not going to get into a ton of detail. Then we'll talk about organizing and summarizing data. And I need to give us more space in these blanks. But we'll talk about organizing and summarizing data in chapters 2 through 4. So, you know, making charts, computing sample means, things like that. And then we're going to talk about analyzing data in chapters 8 through 13. You may notice there's a gap between chapter 4 and chapter 8, right? So what are we doing in chapters 5, 6, and 7? Well, what we're doing in those chapters is we're going to be talking about probability, because the way that we analyze data in chapters 8 through 13 really depends a lot on probability models. And so we have to have some understanding of probability. So that's also what we'll spend a good deal of the course on. In fact, so these first 3 steps, collecting, organizing, and summarizing, that's pretty much going to be unit 1 of the course. And then unit 2 of the course is pretty much going to be probability. And then unit 3 of the course is going to be the analysis of the data. Okay. You may wonder why we bother studying statistics, why you are being forced to take this class. And the truth is that statistics is really useful. It's really useful in a lot of different fields. Basically, any field where you're going to be looking at data, having a knowledge of statistics will be helpful to you. And, you know, I'll be honest, you may not be actually running the statistical analysis yourself, but you'll need to know what people mean when they say, oh, the correlation statistic here was, you know, R equals whatever, or the p-value on this hypothesis test was, you know, this other thing. And that's what we hope to do in this course, is to expose you to those kinds of ideas so that you understand them when you get into the real world. And this really will be one of the most applicable math courses you've ever taken in your life, right? So statistics is a really good course, really, really applicable in the real world. Like I said, any place where you'd be looking at data, and we're living in an increasingly data-driven world. So anywhere you're looking at data, statistics is going to be useful. Anyway, so the reason that we look at statistics is because oftentimes we're trying to say something about an entire population. So a population is like the entire group of individuals that we're interested in knowing information about, right? But it's usually impossible, and if not impossible, it's just incredibly difficult most of the time to get information about every member of a population. And so instead, We take a sample. Right? A sample is just a subset of the population. It's some of the individuals in a population. So this is a nice kind of visual right here, you know. So you've got a group of individuals and then a sample of individuals within the population, right? So the population is the entire group of individuals that you want to know stuff about. The sample is the group of individuals that you actually collect and study. And the idea in statistics is that we want to use the information we collect about our sample to say something about our population at large, right? That requires some extrapolation, and that's where statistics is useful. So to give you an example, it's like if you are interested in like the height of adult males, then your population would be all of the adult males in the world. It's going to be really difficult for you to go out and measure the height of every adult man that is currently alive, right? So getting information about the entire population is next to impossible. But what you could do is take a sample of some adult men, and then based on that sample information, try to say something about the entire population, right? And that's what statistics is all about. So the characteristics of the individuals within the population, the characteristics that we're interested in looking at, those are called variables, okay? And the list of values that a variable assumes is called data. So that's what we mean by data. So in other words, the variables are the categories of information. And the data are the actual observations, right? They're the observations. Okay. For example, hair color is a variable, but the observations, black, brown, blonde, red, purple, green, right? That's data, okay? Well, okay. So, for example, this one says, a researcher is interested in the height of adults who live in Visalia, California. So she collects information about 5 adults living in Visalia and finds that their heights are 61, 67, 74, 63, and 70 inches. Okay. So what's the population in question? So go ahead and give the video a pause and see if you can answer these questions on your own. So I'll let you pause the video and see if you can do this. I'm going to go ahead and give you my answers now, okay? So what's the population in question? Well, she wants to know the height of adults who live in Visalia, so the population in question would be adults in Visalia. Part B asks, what is the size of the sample? Well, it says she collects information about 5 adults living in Visalia. So I think our sample size would be 5. Okay, part C, what is the variable in question? In other words, what's the category of information she's interested in looking at? Well, in this case, that would be height, right? So height, that's the variable. So height. And then finally, what's the data, right? The data are the actual observations, right? They're the individual heights of each of the 5 people that were in her sample. So in this case, it was 61 inches, 67 inches, 74 inches, 63 inches, and 70 inches. Okay? So that's variables and data. Another set of definitions that will be useful for us, and these are words that we'll use throughout the semester, are parameters and statistics, okay? So a parameter is a numerical summary of data collected from an entire population. So if you happened to have information about the height of all the individuals in the world or whatever, or in this case, using our previous example, if you knew the height of every individual in Visalia, right, then this, for example, the sample mean of those, or the population mean of those heights would be a parameter, right? A statistic is a numerical summary of data collected from a sample. So the mean of these 5 individuals would be a statistic, okay? So the average height of all adults living in Visalia is a parameter, whereas the average height of the 5 individuals in this particular sample is a statistic. And oftentimes, we're trying to estimate the value of a parameter based on the value of a statistic. Okay. So here's another set of examples. It says determine whether the given values represent a statistic or a parameter. Again, I'll let you pause the video and see if you can identify each of these as either statistics or parameters. Okay, here's my solution. This first one says a researcher randomly selected 35 movies and found the amount of money that they grossed from ticket sales. The average is $123.7 million. So I'm going to call this one a statistic. The reason I'm going to call it a statistic instead of a parameter is because the researcher only selected 35 movies. They didn't look at every movie ever made, right? They only took a random sample of 35 movies. So this number right here, 123.7, that average is the average of a sample, right? So it's a sample statistic. Okay. Part B, at College of the Sequoias, 13,703 students are male and 16,311 are female. Those would be parameters, right? Those are parameters for sure. Parameters, right? Both of those numbers are parameters because they looked at every student at College of the Sequoias, right? Okay, part C. According to a survey, 42% agree with President Obama's executive actions on gun control. Oh, these are outdated notes, right? Who's President Obama? Anyway, no, yeah, but we'll just go with it. So according to survey, 42%. Now I'm going to call this a statistic, and here's how I know it's a statistic. I am an American citizen, and nobody called me to ask me my opinion about President Obama's executive actions on gun control. So this 42%, it can't be a parameter, right? It's got to be a statistic. It's got to be based on a sample. Since no one called me, they didn't get information about the entire population. Okay. And then part D, in New York City, there are 3,250 walk buttons that pedestrians can press at traffic intersections. It was found that 77% of those buttons do not work. This is kind of a ridiculous question. I don't know if you've ever been to New York City. I took a trip to New York City recently, and they don't have any walk buttons because you know what happens? When you come to an intersection in New York City, because there are so many people in the streets all the time, they just automatically, like their little walk signs, they just automatically change, right? So they don't have a need for a button. So again, we're kind of pretending. Or maybe this is like, again, outdated information. But based on this, I think it's pretty clear they're describing a parameter here. This 77% is a parameter because it seems like they're looking at all of the walk buttons in the city, right? They're not just, they didn't just take a sample of some of the walk buttons. They're saying in New York City, there are this many walk buttons, and out of those, right, 77% do not work. Boy, could you imagine if that was true? That would be pretty sad. But anyway, that 77% is a parameter for sure. It's definitely a parameter. Yeah, because they're talking about all of the walk buttons, right? Not just a sample of some of them. So hopefully that makes it pretty clear, you know, the difference between statistics and parameters. Last page in this section, it says, so qualitative, so what we want to do on this last page is just talk about different kinds of variables that we could see, because the types of statistical analysis that you can run depend on whether you have, depend on the kind of variable that you're working with, okay? So there are two broad categories of variables that we're going to look at. The first ones are called qualitative or categorical variables. And these are variables whose observed values are not obtained by measuring or counting. And in fact, they're usually not numerical. Sometimes they are, but usually they're not. If they are numerical, then they're not mathematically meaningful numbers, okay? So examples of qualitative variables would be things like hair color, right? You don't count someone's hair color, right? You look at their hair color and then you determine, you have blue hair or whatever, right? So hair color, type of car, cell phone number, even though it is a number, it's still categorical because you didn't get that number by measuring or by counting. It was just a random string of digits that was assigned to you, right? So those would all be qualitative variables. A quantitative variable, on the other hand, is a numerical measure. It's a value that you get by either measuring or counting, right? So examples of quantitative variables would be things like someone's height, right? You measure that. Someone's driving speed, okay? You measure that. The number of books that someone owns, you count that, right? So these are all quantitative variables. Now, within the category of quantitative variable, there are two subcategories. We have discrete variables and continuous variables. The values of a discrete variable result from counting them, whereas the values of a continuous variable result from measuring something. Okay, so examples of discrete variables would be number of books you own, number of people living in a household, number of shoes in your closet, right, and so forth, right? Things that you count. Whereas examples of continuous variables would be things like height, weight, speed, temperature, right? Things that you measure. Okay, so just to make this like super as clear as I can, because this is something that often confuses students, right? So oftentimes when I ask students to you know, categorize a variable, like is this thing discrete or continuous, blah, 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 a lot of times students will think that they have to make two choices. They have to decide if it's qualitative or quantitative, and then they have to decide if it's discrete or continuous. And that's just not true, okay? A variable can only be discrete or continuous if it is quantitative. So these two things, discrete and continuous variables, those are subcategories of the quantitative variable, right? In other words, it does not make sense to say that something is qualitative and discrete. Doesn't make sense, okay? Doesn't make sense to say that something is qualitative and continuous, right? That can't happen, right? The qualitative variable is just something that describes the quality of something, right? Its color or its type, right? Whereas a quantitative variable is something that describes its quantity. It's something that you get from measuring or counting. If you counted, then it's a discrete variable. If you measured, then it's a continuous variable. So we only talk about discrete and continuous variables if the variable is quantitative. Okay, so I hope I've made that perfectly clear, as clear as I can. Here's one last set of example problems here. So again, go ahead and pause the video and see if you can work these out. It says determine if the variable is qualitative or quantitative. If it's quantitative, then also determine if it's discrete or continuous. Okay, so go ahead and give the video a pause and see if you can do that. Okay, so here are my solutions. I'm just going to write, okay, so citizenship status, qualitative. Number of children in a household, that's quantitative. Since it's quantitative now, I can decide, well, is that discrete or continuous? So it's quantitative and it's discrete because you count the number of children in a household, right? You count that. I'm going to say discrete. Temperature on a thermometer, again, quantitative. But this time we measured that, right? Since we measured it, we would call it continuous. Okay, marital status, qualitative. I'm just going to abbreviate. Number of students in an algebra class, quantitative, discrete. Gender, qualitative. Age, quantitative. Ooh, since it's quantitative, we have to decide if this is discrete or continuous. Now, if you paused the video and you tried this out and you got to this problem and you wrote down discrete, probably it's because you're thinking, oh, well, I count the number of years that I have been on God's green earth, right? And so it's a discrete variable. Except that you don't actually, when you think about age, age is a measurement of how much time has elapsed since the moment you were born. And theoretically, we can measure that age down to any desired level of accuracy. Like, so for example, I'm 33 years old. I just turned 33 years old. So I could say that I'm 33, but more accurately, I could say, well, I'm 33 years old, 3 days, 4 hours, 27 minutes, 32 seconds, right, and et cetera, et cetera. So, so really, my age is something that's measured. It's a measurement of how much time has passed since the moment I was born. So this is a continuous variable. And then finally, social security number. This would be a qualitative variable. Even though it's a number, it's not a mathematically meaningful number, okay? You didn't get your social security number by counting or by measuring. It was just a random string of digits that was assigned to you when you were born, okay? So that's that. Now, here at the bottom of the page, okay, you'll notice that you have, if I can get rid of this thing somehow, I can't. Well, you'll notice that you have this homework assignment, right? 1.1, number 7 through 29 odd, 33 through 47 odd. Those are problems out of the textbook, okay? So, so when you go into, My Math Lab or whatever to access the textbook, and you're looking around for an assignment in My Math Lab itself, you're not going to find one, okay? Or if you do find one, it's not going to be one that I've assigned for you. It's just going to be kind of a random assignment that just exists in My Math Lab for some reason. The problems that I actually want you to do are in the textbook, right? At the end of the section, at the end of 1.1, there will be a list of exercises in the textbook. I want you to work out your solutions to those on a separate sheet of paper, and then you'll turn this in to me later on in the course, okay? But that will do it for 1.1. Let me see if I can figure out how to stop recording now. It's easier to do this. Oh, it's easier to do this when I'm working on a computer. Okay, there it is.